give this a shot. I'm going to pick up over here. The question says, this is part B, or rather show that the speed of the car as it passes the truck is, and then there's your expression down the bottom, okay? So can you see what I've done? It's just a substitution, you just got to know where you're substituting into. It's about the velocity of the car at a known time and with a known acceleration. So I'm kind of doing two substitution at once, okay? So I'll pop my A in right there, pop my T in, and then everything just kind of comes out in the wash nice and easy, okay? Now here comes the interesting part. We need to use that equation down there, this bit. And we need to use it to answer part C. Now look at it for a second with me. The objective of the driver of the car is to spend as little time alongside the truck as possible. What strategies could the driver employ? Okay, so let's think about this for a second, right? Remember what's going on. We want to overtake, we want to do it fast, okay? So if you're trying to cover a large distance, like overtaking the truck, in a small amount of time, what is the first most obvious strategy that you should employ? You want to go as fast as possible, right? So that's the first thing. We assume there's some kind of speed limit in play, so it's like, well, just hit the speed limit when you're overtaking. Okay, now just mark that, and this is actually worth even writing because it's counterintuitive in terms of the implication that it has, right? We want to hit the speed limit at the point of overtaking. Now this might seem like, well, obviously, is that it, right? I want you to have a look at this equation we've just written down, right? The velocity of the car. To make this thing as big as possible, have a look down at all of the bits and pieces that go into this expression. Okay, let's take them one by one. Capital V. Can we change capital V? No, we can't. It's constant, right? But not just is it constant, like what kind of constant is it? And the answer is, well, in this situation, who do you think is defining capital V?
The truck.
The truck is defining capital V, right? It has its own maximum speed and you're like, oh, I'm stuck behind it. That's the problem, okay? So it's not just that it's a constant that you're not in charge of. Does that make sense? Okay, look again. What's the next one? This C here. What is C? This is the distance between the car and the truck. Now this is also a constant, but unlike V, I can make this whatever I like. Does that make sense? Okay. Now, one last constant, L. What's that again? That's how far I am from the overtaking lane. Does that make sense? So this is like right now. Okay, what's my option here? Okay. Now again, I can't change that because the truck is where it is. Okay. So I have a single quantity that I have control over, a single constant, I should say, capital C. Now, if you told me go faster, go faster. So if this whole expression here, if this is the velocity of the car, and this is the only thing I can affect, then do I want this number to be big or small?
Big.
I want the whole thing to be big, right? So therefore, being that I can't control this, this is on a numerator, right? It's not an inverse proportion, it's not inverse variation. This is on the numerator, so the bigger this is, the bigger the whole thing is. Now just pause for a second. What does that mean? If you want to overtake the truck faster, you should be further away. How does that work? Think about it. How does it work? What do you read?
You won't have to accelerate.
Okay. Right. So if I'm further back over here, okay, I'm going to give you a slightly different picture now. Okay. I want you to picture a guy who's going to have a standing start for a 100-meter race. Okay. So here's the race over here. Okay. Now you've timed it. You're behind. Okay. You're behind. What you want is to be able to, you have to both start running from this position. Think of that position as the start of the overtaking lane. Okay? Aha. So what you want is if you both have to start there, you want the biggest run up you can, right? So the instant when they just start going, you're already shooting off like a bullet. Does that make sense? Okay. So any of you have, I used to coach touch football, right? Any of you who have played touch football know when the ball is here, right? Like someone's just been, touched, and so it's like, okay, I'm gonna pick up the ball now, the dummy half, and I'm gonna pass it to you, right? The person who's gonna receive, they're like way back there because they've got to have a massive run up. Does that make sense? Because it's like, look, this is where I have to start, so therefore I might as well start from there at the biggest velocity I can, and that comes from making this distance, which is counterintuitive, go faster by being further away. It's counterintuitive, but that's what the numbers, that's what the expression tells you. Does that make sense? So we've got two things. Maximize speed within speed limits. Number two, in order to do that, maximize the distance between you and the truck. Okay, now we're ready to do the final part of the question. Part D, read it with me. There's quite a bit to read. The speed limit's 100 k's an hour. Truck's traveling at 90 k's an hour. And this distance here, this gap, is 50 meters. Okay. How far before the overtaking lane should the car begin to accelerate to do what we wanted? Okay. So, there are some easy bits and some hard bits. The first thing I note is that I want to get to the velocity of the car being 100 kilometers per hour. But look carefully at the question and how it's defined. V and, or actually all of our velocity functions, all that kind of thing, they're all going to be in meters per second. So you can see here I've done a pair of conversions, right? I had to convert this, my current speed, that's capital V. And this, which is my target speed, that's the you telling me, go as fast as you possibly can. That's when I want to hit it, okay? So it's going to be, you can see how I did that conversion, right? To get from 100 to 90, I multiplied by 10 on 9. So anyway, those are the numbers, okay? So what I want is to get the velocity of the car to be this. This is my mass, right? 250 on 9. This is the left-hand side of my equation that I just did in part B. I want that velocity to be 100 kilometers per hour, 250 on 9 meters per second. What is my current velocity? 90 k's an hour, which is 25 meters per second. Okay, I've got a 1. Tell me what's going on in here. What have I got? What's known, what's unknown? C is the distance between the car and the truck, and I know that. That's a given quantity. That's 100. Well, it's 50, but you have to double it. There's a 2C on the numerator there. Yeah, you with me? And then there's L, right? That's how far away the truck is. Nope, the truck. It's how far the truck is from the overtaking lane. That's the only pronumeral unknown that I have. So can you help me solve? What would you like me to do? How about divide both sides by 25, which will give me 10. Okay. 10 on 9, 1 plus this guy. What would you like me to do? Subtract, which leaves me with 1 on 9. And now I can cross multiply. Have I answered the question? Not at all, because there's words in this question and I need to explain what's going on. L, of course, is this distance over here. Do you love my two-scale diagram? Okay, so this apparently is 900. The question says how far before the overtaking lane should the car begin to accelerate? So if this is 900, where's the car? It's 950 meters away from the overtaking lane. You see what's going on? Okay. So being that L is 900, that distance, therefore, car should begin accelerating. I even put a tiny bit of work in here. 900 plus that distance, 950 meters from the overtaking lane. And well done. You just put yourself in that category of people who can do extension questions in a Cambridge textbook.